What up, athletes? Whoop, whoop. All right. This is all the theorems and postulates that are going to be introduced in 12.6. You'll notice, by the way, I always put a P above the number or a T above it to separate theorem from postulate. Okay? And we're going to start today with the protractor postulate, which a protractor, if you haven't seen one, just looks like this. Right? It's a half circle. Okay? And what this is saying is every angle has a measure between 0 and 180 degrees. So every angle we're going to be looking at is going to have that measure between 0 and 180 degrees if we're using a protractor. So if KJ is placed along the protractor at 0, right? So we place a line along. See my nice little protractor that has 0 detail pretty much, other than 0 degrees, 90 degrees, and 180 degrees. Placed along the protractor at 0, then the measure of angle JKL is between 0 and 180 degrees. It's just saying, because I'm going to have KL that's going to be somewhere in between J and M, it's going to be somewhere between 0 and 180 degrees. That's all it's getting at. Next, we have angle addition postulate. Now, some of these you'll notice I wrote the title down below. I'm sorry. I had started to write the definitions before I wrote the titles. I was like, what am I doing? But angle addition postulate, D is the interior of angle ABC if and only if the measure of angle ABD plus the measure of angle DBC equals the measure of angle ABC. So an interior angle, you'll notice I drew 3 arcs to represent that entire interior angle, okay? And what we're saying right here is D is the measure of angle ABC, which, please forgive me, A, B, C, I forgot to put my points, and D goes right here. If and only if the measure of angle ABD plus the measure of angle DBC is equal to the measure of angle ABC. Right? It's just saying, basically, it's another one of those, the sum of the parts equals the whole postulates, but it's for angles. So angle addition postulate. We can add 2 smaller angles inside of an angle to get the whole angle. Okay, let's start right here. Now we have the supplement theorem. This says if 2 angles formed, or if 2 angles form a linear pair, then they are supplementary angles. So that makes sense, right? If they're a linear pair, they form a line, which means they add to 180 degrees. Therefore, they're supplementary. Measure of angle 1 plus measure of angle 2 equals 180 degrees. That's easy, but we made a theorem out of it, so you can use it. Theorem 3.4 is called the complement theorem. Very similar to this. If the non-common sides of 2 adjacent angles form a right angle, then the angles are complementary angles. All right? So we're just saying we have these 2 non-adjacent sides, right? Or, excuse me, non-common adjacent. So these are adjacent angles. These are the non-common sides. If they form an angle that's 90 degrees, then the sum of angles 1 and angle 2 are going to equal 90 degrees. That's all this is saying. And then we have another 3 here. Again, you're going to notice congruence, reflexive, and symmetric, but this is for angles. We did it for segments a few minutes ago. And it's just this. Properties of angle congruence. Reflexive property of congruence is just angle 1 equals angle 1. Symmetric is if angle 1 equals angle 2, then angle 2 equals angle 1. And then transitive, if angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then angle 1 is congruent to angle 3. That's it. Same things we did for segments, but we just have to restate it for angles. Isn't that weird? But true. Then we have the congruent supplements theorem, and it says this: angles supplementary to the same angle or 2 congruent angles are congruent. So in other words, if the measure of angle 1 plus the measure of angle 2 equals 180 degrees, so they're supplementary. And we're saying the measure of angle 2 plus the measure of angle 3 are 180 degrees. It's kind of like the transitive property, right? They're both supplement to the same angle, therefore they're congruent to each other. I know I didn't draw them congruent clearly. However, I'm not an artist. Congruent complements theorem, very similar. Angles complementary to the same angle or 2 congruent angles are congruent. If the measure of angle 4 plus the measure of angle 5 equals 90 degrees. 4 plus 5 is 90 degrees. Then we're going to say 5 plus 6 is also 90 degrees. Then it must be that angle 4 is congruent to angle 6 because they're both added to the same angle. Again, it's just an offshoot of the transitive property, but for angles. Believe it or not, we have another page of these things. 12.6 was thick with this stuff. It was just throwing it down. A lot of this, though, you've seen. In fact, you've seen all of this before in some fashion. You just didn't realize it. Vertical angles theorem. If two angles are vertical angles, then they are congruent. We already know that. But we have to say it in the theorem. It's just, again, saying those opposite angles that are diagonal are congruent. Right angle theorem. So these are all theorems following that have to do with right angles. Perpendicular lines intersect to form four right angles. Notice I start using more and more shorthand as I go along. Get used to it. It's okay. So if they're perpendicular, by definition, they meet at right angles, which means all the angles become right angles. Just is what it is. All right angles are congruent. Well, if they're all right angles, then they're all 90 degrees, which means they're all congruent, but you still have to say it. Perpendicular lines form congruent adjacent angles. That's true. If they're perpendicular, then the adjacent angles, those are the angles touching each other, angles touching each other, are going to be congruent. Because why? They're going to each be 90 degrees. And then last but not least, if two angles are congruent and supplementary, then each angle is a right angle. Okay, so here's what we're saying. We're telling you two angles are the same angle, and they add up to 180 degrees. That means you take 180 divided by 2, because they'd have to be equal, right? And that equals 90, which means they have to be 90 degree or right angle. Believe it or not, we actually have just one more. Whoa, that was a lot of theorems, but a lot of them are just stuff you've heard before. They're offshoots, but they have to give them a name so you can use them in proofs. Theorem 3.13 is if two congruent angles form a linear pair. So they're angles that are congruent and they form a linear pair. Remember, we have that other theorem that says if they form a linear pair, then they must be supplementary. And if they're supplementary, that means they're equal to 180 degrees. Divide 180 by 2, it's 90. That's all this is saying. Then they are right angles. Boom. It was your last right angle theorem. Okay. A lot of stuff to do with right angles because we're going to be doing a lot with right triangles eventually. So maybe not this year, but in the years to come. All right. With that said, peace out.